Okay, so what we're going to do today is we're going to use balanced chemical equations and their coefficients to relate reactants and products to each other. So what they've done in your book is they have incorporated an axle to compare the fact that if I have moles of substance A and I want to go to moles of substance B, I would have to use coefficients in the balanced chemical equation in order to make that happen, okay? And so if you take a look at the next page, when we use coefficients to convert moles of A to moles of B, it's typically called using a mole ratio. So let's turn to the next page. This is really easy to do. I'm going to show you in the first set of practice problems how to apply this, okay? So on the next page, let's go here. Unfortunately, we don't have the balanced chemical equation, but we'll be writing it in. It won't take us that long. For number one, it says how many moles of ammonia would be formed by combining 15.7 moles of nitrogen gas with an excess amount of hydrogen gas. Okay, so we've got nitrogen, which is N2, combining with hydrogen, which is H2, and we're making ammonia, which is NH3, okay? I need a 2 in front of NH3 to balance the nitrogens, and then a 3 in front of H2 to balance the hydrogens, and then we have a 1 in front of N2. This is what I do to solve these problems. I take the number that I'm given, which is 15.7 moles of nitrogen. I'm going to write that here, just so I know where I start. And then since we're solving for moles of ammonia, I would recommend putting a question mark moles underneath NH3, so I know what I'm solving for. So take what you're starting with, 15.75 moles, put the chemical formula after it, and then this unit is going to get written on the diagonal of a fraction because we're trying to cancel it. So moles of N2 will follow us down here, okay? And then the coefficient that's in front of N2, which is a 1, that will come down here. And then we're converting to NH3, so you're going to write moles of NH3 on top, and then put the coefficient in front. So we're going to multiply 15.75 by 2, and I've got 4 significant figures here in 15.75. This number 2 and 1 have infinite sig figs, so that means you will have 4 significant figures in your answer. And we've got 31.50 as our result. What do you think? Easy? Okay, so these are one-step conversions, moles of A to moles of B. I believe in your chapter review packet, underneath this section, I gave you a big review packet. Same side. Under section 4.5, there's a picture, and it's the very first one, moles of A to moles of B. I would follow along in the review packet so you understand which math setup pertains to what I'm talking about. It will just make a lot more sense, okay? So moles of A to moles of B is what I just did. Okay, do you want to try one on your own? Yes? Okay, why don't we take a look at number 3, and why don't we write the balanced equation out together, and then you guys can do the math, okay? So for number 3, it says how many moles of calcium metal would be required to replace 1.86 moles of silver from a solution of silver nitrate. Okay, so I've got calcium metal reacting with silver nitrate, which is AgNO3. The calcium and the silver will switch places. It's a single replacement reaction. I'll kick out silver and I'll make calcium nitrate. Okay, so here's my balanced equation. You take it from here. Okay, did you guys get something that looked like that? Yes? Okay. All right, then we can move on to mass problems, okay? So this is going to be the second math setup that you see in the chapter review packet. It's grams of A to grams of B. So all that I'm doing here is I'm still keeping this one-step mole conversion in the setup, but I'm going to add a step to the front and a step to the back. So that means I'm going to convert grams to moles, then I'm going to use the coefficients, and then I'm going to convert moles to grams on the end, okay? So these setups are always the same. So if you take a look at, love it when this happens. Where am I? Here? Yeah, here we go. Here they're showing you that if you've got grams of A, you can convert grams of A to moles of A by dividing by the molar mass. We can go over to moles of B by using the mole ratio or the coefficients. And then you can convert moles to grams of B here by multiplying by the molar mass, okay? So I will write out the setup for you here. Okay, so let's go to the practice problems and let's take a look at practice problem number 1. Okay. Do I need to write the math setup out for you if you've got it in your chapter review packet? Or are you, yeah. Okay, so here it says what mass of oxygen gas, so this is oxygen here. So I'm going to be solving for grams of that, would be formed by the decomposition of 45.65 grams of KClO3. So this is my KClO3, and this is what I'm given. Okay, so that means whatever given mass you have, you will start with it here. We're going to call that grams of substance A. You're going to divide by the molar mass of substance A here. You'll put 1 mole of A on top, and then you're going to put the coefficient on A here, and this would be your moles of A. You're going to put the coefficient on B up here, and this will be your moles of B, and then you're going to multiply by the molar mass of B. And that's how you'll solve the problem. Okay? Now, here, I'm given 45.65 grams. So we're going to start with that. And then my chemical formula is KClO3. That's my A. Then we will divide by the molar mass of A, which is the molar mass of KClO3. I've already added that up for you. It's 122.55. Okay, so these units will now cancel, and that's how I get to moles of KClO3. Next, we use the coefficients. The coefficient on KClO3 is a 2. So this 2 will come down here. And then we're going to oxygen, so the 3 on the oxygen will go here. Okay. And these units match because we're trying to cancel them. Okay. Lastly, I have 1 mole of oxygen, and then I put the molar mass of oxygen on top, which is 32 because I have to multiply it by 2. Okay, so these units match because we're trying to cancel them. Since we're multiplying and dividing, we go with the fewest sig figs, which would be 4, because I have 4 sig figs here. The 1 is infinite, the 3 and the 2 are infinite, this 1 is infinite, this would be 4 sig figs. this would be 5 sig figs. Okay. So you should end up with 17.88 grams of O2. Okay. Okay. Can I move on? Yes. Okay. Now, you may get a problem where they give you kilograms instead of grams. So for instance, right here in number 2, they give you kilograms of hydrogen gas. So obviously you would need to convert kilograms to grams first before you do all of this, okay? And if they ask you to determine the mass, I know I've said this before, that implies you're solving for grams, unless they tell you otherwise, okay? And then let's take a look at number 3. I just want to make sure you're aware of all the different scenarios that you might encounter, okay? So for number 3, here they're asking you to solve for moles. So here it says how many moles of boron would form from 500 grams of boron trichloride with a bunch of hydrogen gas. So what they've done is they've given you BCl3 combining with hydrogen gas to produce boron and then I think hydrochloric acid. Yeah. I'm not going to balance it. I just want you to see that they've given you 500 grams of BCl3 and they want to know how many moles of boron. This means this is just a 2-step problem. You can drop the last step off, okay? So you would convert your 500 grams of BCl3 into moles by dividing by the molar mass. I'm not going to include everything, I'm just showing you. And then you're going to have the coefficient of BCl3 here, and then you'll have the coefficient of boron here, and you're done. Okay, so no need to convert from moles of B to grams of B, okay? Then we've got a different variation in number 4. Okay, so number 4 I definitely want to take a look at. So for number 4, this is a chemical reaction between sodium metal, which is an active metal, and water, which I typically write as HOH, okay? Sodium and hydrogen will switch places. It'll bubble, you'll get hydrogen gas and sodium hydroxide. So your balanced chemical equation would look something like this, okay? They want to know how many moles of hydrogen gas, so I'm going to put question mark moles, would form if 2 moles of sodium react with a bunch of water. And then it says, what volume would this gas occupy at STP? Okay, so hydrogen is your gas. So they want to know the liters at STP. You know from a previous section that you can use a mole of any gas occupies 22.4 liters as long as they mention that you're at STP. So we can use that shortcut after we get to moles. Let me create another video. Hold on.